Safety is not optional. Safe isolation procedures are fundamental to protecting workers from the dangers of live electrical systems. In this video, I'll demonstrate a correct, compliant safe isolation procedure using Martindale equipment. Before starting any work, it is extremely important to ensure we have the correct, compliant equipment. Today I'm using the VI 13800, a 2-pole voltage indicator compliant with GS38 and BSEN 61243. I'm also using a dedicated proving unit, the PD440 SRD matched to the voltage indicator, plus lock-off devices and warning tags, in this case items from the Martindale Lock Kit 1. I will also perform an additional check to ensure the exposed metal parts of this AC installation are not live. To do this, a single pole voltage indicator will be used, the Martindale VT7. Multimeters and non-contact voltage sticks are not suitable for proving dead. It is far too easy to make a mistake with a range setting or dead battery. Before isolation begins, permission must be obtained from the duty holder or authorised person. A risk assessment and method statement must be in place. Safe isolation is a controlled process, not a guess. Before touching anything on this AC system, I perform a live metal check using the VT7 single pole indicator. I'm checking exposed metal parts and screws and the enclosure itself. If any dangerous voltage is detected, work stops immediately. This step is critical, especially where wiring faults, diverted currents or shared neutrals may exist. Next, I prove my voltage indicator before use. I'm using the PD440 SRD proving unit, which is safer than relying on a live circuit. You cannot guarantee there will always be a suitable source available. This confirms my indicator is working correctly. I now confirm that the circuit is live using the voltage indicator. This step proves both the circuit and the tester are functioning correctly before isolation. I now identify the correct point of isolation and switch it off. Using the Lock Kit 1, I secure the device in the off position using a unique padlock and key, then apply a warning tag. The unique padlock ensures re-energisation remains under my control at all times. No lock-off means no safe isolation. With the circuit locked off, I now prove dead. For single-phase systems, I carry out 3 tests: earth to line, earth to neutral, and neutral to line. Each test confirms the absence of dangerous voltage on the circuit I intend to work on. In the case of 3-phase systems, I need to carry out 10 tests: E to L1, E to L2, E to L3, E to N, N to L1, N to L2, N to L3, L1 to L2, L2 to L3, and L3 to L1. Before work begins, I reprove my voltage indicator on the proving unit. This confirms that the tester has not failed during use and the results I've seen can be trusted. The circuit is now safely isolated and proved dead. Work can now begin. If work stops at any point or conditions change, the circuit must be rechecked before continuing. Once work is complete, re-energising must follow a controlled process. Complete required dead testing. Remove lock-off devices and tags. Restore supply. Carry out live tests and commissioning, and complete all relevant certification. Safe isolation saves lives. Follow the procedure, use the right equipment, and never assume a circuit is dead. This is safe isolation the Martindale way. Check out our live page on our website for more information and downloadable resources.